Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning, students, and today's topic is charge separation, that is how charges get separated in clouds. So here today we are going to deal with three theories based on charge separation. So the first one is Wilson's theory, and the second one is Simpson's theory, and the third one is Reynold and Mason's theory. So now let's move on to the first theory, that is Wilson's. So Wilson's theory is completely based on assumption. So we all know that in our atmosphere there is large number of ions, dust particles, water particles, and so many gases, etc. and etc. right? So normally what happens is these ions, that is ions in the atmosphere, they get attached themselves towards the small dust particles and water particles. So although there will be electric field in the atmosphere, so which is invisible, so these electric field, they normally move towards the earth, that is downwards, they move downwards, and the intensity of this electric field will be approximately 1 volt per centimeter. And when we consider the surface of the earth, the intensity will be decreased, and normally at a height of 9500 meter, the intensity of the electric field will be 0.02 volt per centimeter. Okay, so as I said in the earlier that the ions in the atmosphere get attached to the water particles. So these ions, what happens is when they come in contact with the electric field, or when the raindrop which is attached to the ion falls on the electric field, what happens is the raindrop get polarized, and the upper side of the raindrop acquires negative charge and the lower side of the raindrop acquires positive charge. So now listen carefully that the particular raindrop consists of charges, and when it gets polarized, the charges are separated, and the lower part of the raindrop acquires positive charge and the upper part of the raindrop acquires negative charge. And now what happens is the positive charges in the lower part of the raindrop attracts all the negative charges in the atmosphere. So now the negative charges get settled at the lower part, and the positive charges get settled at the upper part of the cloud. So according to Wilson's theory, large negatively charged raindrop, that is in large negatively charged raindrop, upper portion of the cloud consists of positive charges, and negative charges will be in the lower part. That is, the charge separation is based on these ions and this electric field concept. And what happens is basically in a cloud, the lower part consists of negative charges and the upper part consists of positive charges. Okay, and now the next theory is Simpson's theory. So how Simpson tells based on charge separation is he classifies, or he divides the entire cloud into three regions, that is A, B and C. So you can see in the figure, the lowest region, that is the lower part of the cloud, is region A, and upper to A, that is region B, and above that, that is the topmost part or the upper part of the cloud, is C. Okay, so what he says, that is what Simpson says, is at region A, when a huge air current with a very high velocity of 800 centimeter per second, that is air current or wind, when it blows at a very high velocity of 800 centimeter per second, what happens is there will be no raindrop. Okay, so there will be no raindrop in the cloud. Also, what happens is, due to this high velocity, all the raindrop breaks, causing the positive charge in the cloud and the negative charge in the air. And then what happens is, the spray is blown upward as the velocity of the air decreases, and similarly the positively charged water drops recombines again with the large water drops and they fall below. So when such action takes place, the region A becomes positively charged. So due to this high air current and the high velocity, and due to the break of the raindrops, the region A attains positively charged, that is positively charged ions. So when region A is positively charged, as we know, the next region B is negatively charged by the air currents or wind. So region A is positively charged and now the region B is negatively charged. And region C. So the region C is something different, that is the temperature in region C is below freezing point. So as it is below freezing point, the raindrops will be in the form of ice crystals. So I think most probably it will be beyond the super cooled state. So the ice crystals, the raindrops will be in the form of ice crystals, and these ice crystals will be having negative charged. So according to Simpson's theory, the lowest part, that is region A, is positively charged and region B is negatively charged, and then region C is negatively charged. Okay, so the next theory, that is the final theory, is Reynold and Mason's theory. Actually, the theory given by Simpson is not up to the satisfied level, and therefore Reynold and Mason proposed a modified theory, so which is known as Reynold and Mason's theory. So what they tells here is, the clouds which are developed at height of 1 to 2 km above the ground level may extend up to 12 to 14 km above the ground. That is, at a height of 1 to 2 km above the ground, the air currents are controlled by the temperature, carrying moisture and water droplets. And the temperature is 0 degrees Celsius at 4 km from the ground, and it may reach up to minus 40 degrees Celsius at a height of 12 km. So normally at this point, the water droplets does not freeze at 0 degrees Celsius. The freezing point will be below minus 40 degrees Celsius. So what happens is, when such freezing occurs, the crystals are grown into a heavy large masses, and due to their weight and gravitational force, they start moving down. So as I said, only they get freezed at minus 40 degrees Celsius, and beyond this temperature, what happens is, these ice crystals, which have a very huge mass and weight, begins to fall down or move downwards due to their gravitational force. So this ice crystals which move downwards is known as hailstones, which travel downward with a negative charge in the lower region of the clouds. And splinters are moved by air currents or wind. They carry the positive charge in the upper region. So according to Reynold and Mason theory, the cloud consists of negative charges in the lower region, that is, which is caused by hailstones, and the upper region of the cloud consists of positive charge, which is due to the splinters. So what we have learned, that is in the first theory, that is in Wilson's theory, how will be the charge separation? That is, in a cloud, according to Wilson's theory, in a cloud, the lower region of the cloud consists of negative charges and the upper region consists of positive charges. And according to Simpson's theory, the region A will be having positive charge, and region B will be having negative charge, and similarly region C also will be having negative charge. And finally, the final theory which was proposed by Reynold and Mason. So according to their theory, the clouds consist of negative charges in the lower region and positive charges in the upper region. So once the charge separation is completed, so as we know, lightning stroke takes place. Thank you.